Hello and welcome. In this video, we're going to be looking at dilutions and specifically the calculations that go along with a dilution. So first off, talk about what dilution is. When you are diluting something, this is simply changing the molarity of a solution through the addition of additional solvent. Okay, so we talk about the concentration of a solution, again, in terms of this idea of molarity, where molarity equals moles of solute divided by volume of solution. And that volume, again, can either be in liters or in milliliters, but traditionally it is done in terms of liters. And when we add additional solvent to this, we change that molarity because we change the volume of the solution. We're dividing by a larger value, so therefore molarity decreases, and that's referred to as dilution. So again, it's the changing of the molarity, in other words, a decreasing of that molarity of a solution through the addition of additional solvent. So in this equation, molarity equals moles solute divided by volume of solution. We can rearrange this to moles of solute equal molarity of the solution times the volume of solution. And the reason we want it in this particular format is because when diluting, the moles of solute do not change. Only the volume of the solvent, and therefore the solution, is what actually changes. Okay? We're adding more solvent, but our mass of solute that we initially put in to produce that solution, we're not adding any more of that. We're not taking any away. So the moles of solute remain unchanged, and it's simply the volume of the solvent and therefore the solution that changes. So all that to say, moles of solute before are going to equal the moles of solute after. So we can take this equation of moles solute equals molarity times volume, and we can look at it before and after. We get the idea that the moles of solute before the dilution are going to equal the molarity before times the volume of the solution before. Likewise, the moles of solute after the dilution are still going to equal the molarity after times the volume of the solution after. And we simplify or condense all this into an equation that is M1V1 equals M2V2, where the 1 and the 2 stand for the before and the after. And when we do dilution calculations, M1, M2, and V2 are known. We know what final volume we want of the diluted solution. We know what molarity we're looking for, and typically we know the molarity of the concentrated solution or the stock solution. So M1V1 equals M2V2, where M1, M2, and V2 are your knowns. What we're trying to solve for is the volume of concentrated or stock solution that we need, that we're then going to put extra solvent into to dilute that solution down. So we take that equation and we rearrange it to V1 equals M2V2 all divided by M1, where again V1 is the volume of the concentrated solution that is needed, that you're then going to add additional solvent to be able to dilute it down. So let's go on and take a look at an example problem. So this problem says, what volume of 12.0 molar HCl is required to obtain 200 milliliters of a 3.5 molar HCl solution? So what volume? This is our question, and it's asking of 12 molar HCl. So this is our starting molarity. Is required to obtain 200 milliliters. This is a volume. And because it's of our diluted solution, I'm labeling it as V2 of a 3.5 molar. So this should be my new molarity, or M2. So again, if I'm thinking in terms of M1V1 equals M2V2, and that is rearranged to V1 equals M2V2 all divided by M1, then I have all the different pieces of information that I'm needing to be able to solve this particular problem. So I'm going to grab my calculator and go on and substitute in the values that I have. So M2 is 3.5 molar. V2 is 200.0 milliliters. And I'll explain in just a moment why we can leave that as milliliters, over my initial molarity of 12.0 molar. So if I take a look at this, the reason why I do not have to change to milliliters is because those units of molarity will cancel out and leave me in terms of milliliters. Okay. Now, in a previous video, I talked about the fact that if you do your volumes in milliliters, for example, if I've got that moles equals molarity times volume, and my volume is done in terms of milliliters, and molarity is done in terms of moles per liter, when I solve, what I will actually get are millimoles. So in this particular example problem, there's two reasons we actually do not have to convert over to liters. The first is that the units of molarities cancel and leaves us just in plain milliliters. The second reason is the idea of millimolar is perfectly acceptable. So now that I've substituted in my values to the equation, plug it into the calculator, so 3.5 times 200, and then divide that by 12.0, and I get volume 1 is 58.3 milliliters. And if I'm looking at significant digits, my 12 molar has 3, my volume 2 has 4, and my secondary molarity only has 2 significant digits. So as a result, this would actually have to be rounded down to just 58 milliliters due to the inaccuracy of that 3.5 molar. If it had been 3.50, I'd have 3 significant digits, and I could have left it as the 58.3. So that is the working of this particular problem. So what we would now do is we'd go into lab, we'd have our stock solution of our 12 molar HCl. We would measure out 58 milliliters of that HCl, put it into an appropriate volumetric flask, and then add water until we get to our specified volume, in this case 200 milliliters. I will say this, because this is an acid, we've got a rule that we always add acid. So other solutions, if I'm diluting, say, a sodium chloride solution, magnesium chloride, anything like that, it's perfectly fine to take the stock, put that into the volumetric, and then add water. In the case of an acid, we always want to actually take the acid first. So I'd measure out the 58 milliliters and have that sitting by, put some water into that volumetric flask, and then slowly add the acid to that, swirling the whole time, add a little more water, a little more acid, swirl. Once all the acid has been incorporated into the water, then I'd finish filling up to that 200 milliliter mark on the volumetric flask. So hopefully all this made sense. If not, feel free to leave me a comment, and I will get back to you when I'm able to, as soon as possible. Thanks. Take care.